Hello everyone! Today me, Nurfarin Farhana, and my friend Shasha Izzati will explain to you about one of the well-known crystal structure named Cesium chloride. Before we dive deeper into the crystal structure, what is cesium chloride? Cesium chloride is an inorganic compound with the formula of CaCl. It is a colorless salt that is an important source of cesium ions in a variety of niche applications. Cesium chloride occurs naturally as impurities in minerals such as carnallite, sylvite, and kyanite. Let's move on to the structure of this beautiful crystal solid. Cesium chloride has a non-closed packed packing type with a primitive cubic lattice. The cesium plus ion is positioned at the center of the cube, while the chloride ions occupy the corners of the cube. When you first look at the structure, you might think, why isn't this body-centered cubic? Why is it primitive cubic? The reason is because this crystal involves two different types of atoms, cesium and chlorine. Cesium atom forms cesium plus cation by donating its one valence electron to chlorine atom, forming chloride anion. The bonding between these two ions is called ionic bonding. The ionic compound is held by a strong electrostatic force. In contrast, it's crucial to remember that the central atom in body-centered cubic BCC lattice is the same type of atom as the corner atoms. Thus, this explains why cesium chloride adopts primitive cubic lattice rather than BCC lattice. Aren't you curious of how many ions or atoms can occupy one single unit cell? We can actually calculate it. The number of atoms or ions found in a single unit cell is called formula unit or Z. Since there are two types of different ions, which are cesium plus ion and chloride ion, we will calculate Z value for both of the ions. As we know, cesium plus cation occupy the center of the cube. Hence, the calculation is shown as ZCS plus equals to 1 center times 1 equals to 1. Why do we multiply one center with 1 and not other number? This is because a formula unit located exactly at the center of the unit cell belongs entirely to that specific unit cell, hence the factor of 1. For chloride ion, it occupies 8 corners of the cube. Thus, the calculation is Z chloride ion equals to 8 corners times 1 over 8 equals to 1. The reason why we multiply 8 corners with 1 over 8 is because each corner of the unit cell is shared by 8 unit cells. So, a single formula unit at a corner contributes only 1 over 8 to the specific unit cell we are considering. Coincidentally, the Z value for both Cs plus ion and chlorine ion are the same, which is 1. Thus, Z value for cesium chloride is equal to 1.
In a cesium chloride crystal structure, each cesium atom is located at the center of a cube, while each chloride ion is located at the corners of the cube. The CaCl distance is equal to the body diagonal of the cube. To find the location of each atom in a CaCl structure, we first need to determine the relationship between the Cs and Cl ions in the term of the unit cell dimension.
Let's assume that the edge length of the cube is A and the diagonal of the face is Y. To find the diagonal length of Y, Pythagorean theorem is used where y square equal to a square plus a square. So we will get y square equal to 2a square. So therefore, we will get y equal to square root 2a. Body diagonal of the cube, which is the cesium chloride distance, also can be determined using the Pythagorean theorem in a cube where x squared equal to a square plus y square. By substitute the value of y square, we will get x squared equal to a square plus 2a square. So x squared will be equal to 3a square. So therefore, the value of x will be equal to square root 3a.
Since the Cs atom is at the center of the cube, its position can be determined by dividing the body diagonal by 2. Cs position will be equal to half square root 3a. The Cl ions are located at the corners of the cube. Knowing that the Cl-Cs distance is the edge of the cube, the position of each Cl ion can be given as Cl position equal to A. Therefore, the coordination number of the cesium ion in a cesium chloride crystal structure is 8, as it is surrounded by a chloride ion. Similarly, for the chloride ion at the corner, it is only in contact with the cesium ion at the center of the cube. So, the coordination number of the chloride ion is also 8. Therefore, the coordination number will be the ratio of 8 to 8.
Moving on to the applications. Cesium chloride contributes in the field of molecular biology and biochemistry. Cesium chloride is commonly used in density gradient ultracentrifugation, a technique to separate nucleic acids such as DNA or RNA based on their buoyant density. Next, cesium chloride also contributes in the analytical chemistry field. Cesium chloride can act as a standard electrolyte because of its high solubility and stability. This makes it useful in calibrating and standardizing the conductivity meter and other analytical equipments.
In industrial and chemical synthesis, CaCl is a key precursor for the production of elemental cesium through electrolysis. Elemental cesium is employed in various applications, including as aggregator in vacuum tubes, in photoelectric cell, and in specialized glass manufacturing. Next, electronic and optical application. Cesium compounds, including CaCl, are used in the production of photocathode, which are used in photoelectric cell and other light detection devices due to their sensitivity to light.
So that's all from us. Thank you!